Okay, so let's try some questions now. So here we have example number 2. So with the example number 2, we have to deal with the rhombus. So before starting the question, let's talk about rhombus a little bit. So in order to have a rhombus shape, the shape needs to satisfy the four characteristics. So first characteristic to have a rhombus, we need to have these four sides. So like all sides of the rhombus needs to be equal. And second, the opposite sides of a rhombus are parallel. And three, the opposite angles of a rhombus are equal. And fourth, in a rhombus, if the shape is rhombus, so the rhombus, the diagonals bisect each other at right angle. So right angle means 90 degree. So in rhombus, diagonals bisect each other at right angle. So if you look at this question here, it says that a rhombus has diagonals of the length 12 centimeter and 8 centimeter. We need to find the smallest angle of the rhombus, right? So diagonals means that we have lines that bisects this shape like this. Okay, so let's use the different color for different diagonals. So one like this and another one like this. And then we know that the longest one has the 12 centimeter, right? And then the smaller one has a length of 8 centimeter. So it means this, since it bisects in the middle, the half of these lines gets like 4 centimeters and 6 centimeters here. Okay, these are its lengths. And we know that in a rhombus, diagonals bisect each other at the right angle, so means the angles here are 90 degrees. Means we can take one of the triangle out and calculate this angle, the smallest, this half of the angle, to find the smallest angle of the rhombus, because this is your smallest angle, right? Means if I say half of the smallest angle is x, then the smallest angle is 2x, right? So that means if I find this angle x, then we can find the smallest angle of the rhombus. So what you're going to do is we're going to take this one of these triangle, the right triangle out. Okay, so we're going to take that right angle out. So let's draw it like this. Then we know that this is 90 degree, right? And this is the 6 centimeter and this is 4 centimeter. And we are trying to find the angle x. Okay, then to find the angle x, since we know that we know the opposite side 4, adjacent side 6, so let's write it. This is adjacent, this is your opposite. Then we can use the tangent theta equals to opposite over adjacent, the trig ratio formula, to calculate this missing angle x, right? So we can say tangent x is same as 4 over 6. Then the x value is same as tangent inverse 4 over 6. Okay, then this will give us the x value approximately equals to 33.6901. And since we need to find the 2x, right, the smallest angle, we have to multiply 2 to the 33.6901 0.6901, then this gives us the value approximately equals to, let's write this answers over here since we don't have space. Then we can say that this is equal to 67.3801. So the answer is approximately 67.4 degree. Okay. Then let's try the example 3. So we have example 3 and a circle, right? So a circle has a radius of 7 centimeters. So a circle means we have a center and it has radius of the 7 centimeter. And a chord of the circle subtends an angle of the 122 degree at its center. We need to find the length of the chord, right? So let's draw another radius line so we can draw the chord, okay? So let's draw another radius line like this. Then we can say that the chord is happening like this way, okay? And we know this is 122 degree according to the question, right? Then since we're just going to use the trigonometric ratio, not the chord formula, then we can draw a line that passes the center and then the midpoint of the chord, right? Then we can say that this is the midpoint of the chord. That means the length of this part and then the other part is equal to each other. Then if we say this half of the length is equal to y, then the length of the chord is equal to 2y. Okay, so we can first calculate the y value and multiply by 2 in order to find the full length of the chord, right? So let's draw a triangle. This triangle is actually the half of what we draw here, right? So I just copy this triangle to here. Then we know that this is equal to y, and this is 7 centimeter, and the angle here is half of the 122. So it's going to be 61 degree. Okay, so we got the angles too. Then we know the hypotenuse. This is hypotenuse, and we know the opposite part of the triangle. Then you can use the sine theta rule, right? So sine theta is equal to opposite over the hypotenuse. So we can say sine angle 61 is same as the opposite, the unknown y, over hypotenuse 7. Then y value is equal to sine 61 times 7, and it is equal to approximately 6.12234. But since we need to find the length of the chord, which is equal to 2y, we have to multiply the 2 to the 6.12234. Then we get approximately 12.2447 centimeter. So the final answer is 12.2 centimeter. So example number 4. So we have a rectangular prism here, and then dimensions shown in the diagram, and then Z is the midpoint of the line WX. So Z is located here, so you can see that it is a definitely midpoint of the line W and X, and it has all the symbols too, right? So question A, we need to find the line VX. So VX means that we have to find the line from the point B to the point X, right? So let's redraw this diagram, okay? We have rectangular shape here, and this is the base of this rectangular prism, and the points are V, Y, W, and X, and we have that point here, right? So this is the base part. We are doing question A, and we want to find the length of the line BX. Okay, let's draw now with another color. We want to find the length of the VX, And we do know that the Vx, this part, has the same length as the Rs and also has the same length as UT, which is given as 9 centimeter. And line XW, this line has same length as ST, and ST also has same length as the RU, so it has 6 centimeter, right? Then we have to find the line V and X, and you can clearly see that this is 90-degree angle. And if I redraw this triangle here, you can see there's a triangle, right? If I redraw this triangle, it actually does look like a triangle, which we can use a Pythagoras theorem, right? So this is 9, this is 6. We have to find the hypotenuse, which is Vx. So we can do Vx squared equals to 9 squared plus 6 squared. By the way, the Pythagoras theorem uses the formula like this, right? C squared equals A squared plus B squared, right? So I'm using this here. Then I can say the line Vx squared is same as 81 plus 36, which is equal to Vx, line Vx is same as square root 81 plus 36, right? Then we can say the line Vx is same as approximately 10.8 centimeter. Okay. Then question B, we need to find the angle RXV, right? So when you look at this diagram, the RXV is actually happening RXV, right? So you can see that this is the triangle again, right? 90 with a 90-degree angle. Then let's redraw this triangle in a new page. Okay, so we need to find the angle RXV. So I'm going to redraw the line again. So angle RX and V, right? This makes a right triangle, right? You can see it here, right? It makes right triangle. So if I redraw this triangle, okay, it does indeed will look like this with R, V, and X, and RV has a length of the 8 centimeter, and we are trying to find this angle. Okay, so question B, we are trying to find the angle RXV. Okay, so the little hat means angle. So little hat thing means angle. Okay, so we are trying to find the angle X, and we know from question A the line V has a length of the 10.8 centimeter, right? Then since we know the opposite side of the angle and the adjacent side of the angle, we can use tangent theta equals to opposite over adjacent, right? Then we can say the tangent theta, or we can say, let's just say tangent angle RXV is same as 8 over 10.8. Okay, then the angle RXV is same as tangent inverse 8 over 10.8, which give us the about 36.5 degree. Okay, then we have found the answer for question B. Okay, then question C was finding angle or the line Y and Z, angle YZ. Okay, so we need to find the line Y and Z. Okay, the Y and Z happens right here. Okay, so this is also makes another triangle. Okay, but this time you need to think about how it looks like in the base part of this prism. In the previous question, with the question A, we figured it out the base shape, right? How it looks like this one, right? This is how it looks like. So let's copy this shape here, and we are trying to find the length of the y and z. And you can see that there is a triangle, the y, x, z, right? And we know that z is the midpoint of the line y, x, and w. So that means the x and z has the length of the 3 centimeter. Okay, length of the y-x is the 9 centimeter. Okay, then we know there is a triangle happening, right? Triangle happening like this. Then we can say that this is y, this is x, this is z. So 9 and 3. We're trying to find this hypotenuse. Since this is right triangle, we can simply use the Pythagorean theorem to do it. So we can say y and z, line yz square is equal to 3 square plus 9 square. Then we can say line yz is same as square root 3 square plus 9 square. So this gives the answer about 9.49 centimeter. Okay. Then let's do question D. Okay. So question D, we need to find the angle YZU. Okay. So angle YZU, let's see where it is happening. So I'm going to erase a little bit here. Okay. We know that the line Y is here, and the Z point is here, and the U point is here. So means we need to find the angle between this and this. Okay, there is another triangle happening, right? Then let's redraw this diagram. Okay, so we can draw like this. If I'm redrawing this triangle, this is U, okay, and this is Y and Z, right? So U, Y, and Z, and we just calculate the length of the line YZ, and then we know the length of UY is same as 8 centimeter. Okay, then we can say that, okay, this is 8 centimeter. YZ line is same as 9.49 from the previous question, and we are trying to find the angle this YZU. Okay. Okay, so this is a question D. So what you can do is, since we know the opposite side of the angle and the adjacent side of the angle, we can use the tangent theta equals to opposite over adjacent rule again. Okay, then we can say that tangent angle YZU is same as 8 over 9.49. The angle YZU is same as tangent inverse 8 over 9.49. Then this is same as, then we can say that angle YZU is approximately equals to 40.1 degree.